Hi everyone, welcome back to 10th standard maths class. In this video, we are going to learn a new chapter. Our next chapter is chapter 7, tangents. Here we have a circle. About a circle, so many things we already learned. Center is there, radius, diameter, and in 9th standard you have learned about chord also. Okay. Then next is tangents. Here tangents means it's a line. Tangents means it's a line which touch a point on the circle. Which touch at a point on the circle. Just to touch a point on the circle. That means like this. Just touch a point on the circle. This is known as tangent. Okay. Only one tangent we can draw through a point. And one more speciality is there. If a tangent is drawn through a point on the circle, that tangent will be perpendicular to the radius through the same point. That means if we are using this point to draw the tangent, then this tangent will be perpendicular through the radius through the same point. Okay, now if we are drawing a tangent from this point, then that tangent will be perpendicular to the radius through that point. So tangent means it's a line which touch the circle, just touch the circle. Okay, only one tangent we can draw through one point. Okay, so many tangent we can draw in a circle, because we know lots of points are there around this point, around this position. Okay, so lots of tangents we can draw. So this is the tangent, and the tangent is always perpendicular to the radius. Okay, so this is the introduction part for this section, lines and circle. Now let's move on to problems from the first activity. Page number 163, first question. In each of the two pictures below, a triangle is formed by tangent to a circle, the radius through the point of contact, and a line through the center. Two figures given. Draw these in your notebook. Here in this question, two figures are given, two rough figures are given. We have to draw these figures by using exact measurement. Okay, so in the first figure, O is the center of the circle, and OP is given as 5 centimeter, and radius of the circle is given as 2.5 centimeter. And you can see that this line PA touch the circle at the point A. So PA is a tangent. Now we need to draw this, but here this measurement length of tangent is not given. Okay, so in order to draw this figure, radius of circle already given, that is 2.5 centimeter. Okay, so first of all, draw a circle of radius 2.5 centimeter. First draw a circle like this using compass. Draw a circle of radius 2.5 centimeter. Okay, so this is 2.5 centimeter radius circle. So circle over. Next is what we need, 5 centimeter line from the center point. Okay, 5 centimeter line towards out. So using scale, measure 5 centimeter from the center. Measure like this, then draw that line from the center point. Draw the line, 5 centimeter line. Okay, so next step also over. Now we need to draw tangents. Okay, tangent from this endpoint, to the circle, we need tangent. So the method is, use your compass. Take the compass and draw the perpendicular bisector of this line. Perpendicular bisector, you know how to draw the perpendicular bisector by measuring more than half. So measure more than half. Draw one arc in the upper side, one arc in the lower side. Same from the next center point also. One arc here, one in the lower side. Okay, then join that two points. Then you will get what? Perpendicular bisector. Here the bisector will be on the circle. Okay, midpoint, because 2.5 centimeter radius circle. Okay, directly we know this will be, the midpoint will be this one, 2.5 centimeter. Now keep the pinpoint of the compass at this point, at the midpoint, and that pencil point in the first center, okay, like this. Then draw one arc in that circle, okay, like this. Like this, draw one arc. Keep the pinpoint at the middle point. That means in that perpendicular bisector you will get one line. So pinpoint at that point, then pencil at the center of the first circle. Then draw two arc in that circle, or you can complete the circle. No issue. You can complete the circle. That also possible. But we need only 2 points on the circle. Okay. So this also enough. Now after drawing that circle, you can see 2 points on the circle. Okay. So this is the point and this is the next point. Here we need only one part. Okay, so from that point, that point you can join to the center and join to the end point of this 5 centimeter line. So from this point, draw a line to the outside point, and from that same point draw a line towards the center. This is the figure. This is 5 centimeter and this is 2.5 centimeter. This measurement no need to measure, just figure is enough. So this is the first figure. In the second figure, radius of the circle is not given. Okay, distance from the center to the outside, it is 4 centimeter, and length of the tangent PA is given as 2 centimeter. But in order to draw the circle we need what? Radius, but that is not given. So OA we need to find here, then only we can proceed. So for that we know OA is the radius and PA is the tangent. Starting I told you PA is from the point A, through the point A, and OA radius also through the point A. So this radius and this tangent will be what? Perpendicular, that is 90 degree. That means we can say that triangle OAP is a right triangle. Okay, so right triangle means Pythagoras theorem we can apply. So 90 degrees opposite side, 4 centimeter is the hypotenuse, 2 centimeter we can consider as base. So in order to find the altitude, what is the equation? Root of h square minus base square. Okay, so that is equal to root of hypotenuse is 4. 4 square is 16 minus base square. Base is 2. 2 square 4. So 16 minus 4, answer is root 12. Now let's simplify this root 12. That is root of 4 into 3. 4 3s are 12. Now root 4 value is what? 2. So take that 2 outside. 2 root 3 is the answer. Now this is approximately equal to 2 into root 3 value is 1.73. 1.73. So that is equal to 3.46. When you multiply this, you will get 3.46 as the answer. That is equal to, let's round the figure because 1 decimal. Okay, because using scale only 1 decimal is possible. So 3.46, second decimal is greater than 5. So cut that and add 1 to 4. So 3.5 centimeter will be what? Radius. Okay, 3.5 centimeter is the radius. So we can draw the figure. Start from 3.5 centimeter radius circle. Draw 3.5 centimeter radius circle. Then mark 4 centimeter away from the center. 4 centimeter, same like the previous case. But here no need to draw the perpendicular bisector because tangent length is already given as 2 centimeter. So after drawing this 4 centimeter line, use your scale. Okay, use your scale and measure just 2 centimeter, just 2 centimeter exactly from the point P. Now from that point you can join to the center. You will get the figure because here tangent already given. For the previous question tangent length was not given, that's why we drawn perpendicular bisector first, then we found this point. Okay, so this is the procedure. Try to do that same like the previous question. 3.5 centimeter is the radius. So first question over. Next is question number 2. In the picture, all sides of a rhombus are tangents to a circle. Draw this picture in your notebook. Here in this question, we have to draw a rhombus around the 4 centimeter diameter circle. 4 centimeter diameter is given, that means 2 centimeter is a radius of the circle. Next is given 40 degree. This angle, complete angle is 40 degree. Now if we draw a straight line, that means a diameter, perpendicular diameter, if we draw this, we can write as 20 degree each. Okay, total 40 means 20, 20 will be. This figure we need to draw. And here all the sides of this rhombus are tangents because it touched the circle. That's why I drawn two lines here. First one, this tangent touched the circle at this point. Now the second tangent, just the opposite side, touched the circle at this point. So we can join that two lines like this. It will be through the center. That means it is a diameter. Now next tangent is also through one point and the opposite side also through one point. That point also we can join. Again we will get one diameter. Okay, because we know radius through one point and the tangent through one point will be perpendicular. So this is the line. Now we can write this is perpendicular. All the sides are perpendicular. This also perpendicular. This will perpendicular. This also perpendicular. That means 90 degree. Now here when we consider only first portion, for example, center consider as O, then P, then A. Consider O, P, A. Here A is 90 degree, P angle 20 degree. Then what will be, this is center angle 90 plus 20, 110 degree. So remaining is 70 degree. Okay, 70 degree. Same for the second part also. Here if we are marking B, O, B, P, here also will be 70 degree. So total angle here it will be 140 degree. Okay, second part also it will be same. Now we have to draw this figure. So first of all, draw a circle of radius 2 centimeter. Draw like this, a circle of radius 2 centimeter. Now in the next step, we are starting from the point A. Okay, a diameter we need. Okay, so first draw a diameter. Without any measurement, just a slanting line is enough. Just draw a diameter here. So first diameter over. Now we need the second diameter. For that, we know from here to the second diameter, between angle is what? 140 degrees. 70 in the upper side, 70 in the lower side. So total is 140 degree. So take the protractor and keep the protractor's midpoint at the center of the circle like this. Okay. Then measure 140 degree. Measure 140 degree in that protractor. So by measuring 140 degree, you get a point here. Okay. Then keep the scale like this through the center. Okay, from this point. Now only inside portion we need. Draw inside one next diameter like this. Okay. So here this will be 140 degree. The next will also be 140 degree. Okay. So first portion over. The cross line we got. Now we got 4 points. One here, second point here, third point, fourth point. 4 points we got. Through these 4 points we need what? Tangents. Okay, then it will be a rhombus. So in order to draw the tangents, we know what? Perpendicular. The radius and the tangent is perpendicular. So in order to draw the tangents, you can use a protractor because it is perpendicular line. So take the protractor. First we are going to draw tangents from this point. Okay, so from this point means through that point diameter is this first line. Okay, now this line must be same as for this 90 degree perpendicular line. Okay, it must be on the same position. So keep the protractor like this. Just that point must see, only that point must be visible. The remaining portion must be under the protractor. Okay, so keep it like this. That middle point, that means that 90 degree line and that diameter must be in the same line without any slanting. Okay, so keep it like this. This point must be visible, only that point. The remaining portion must be inside the protractor. Then just draw a line here. Draw a line like this. So this is the first tangent through this point. The same procedure you have to repeat for the remaining 3 points. Keep the protractor in the next diameter. Next diameter only this point must be visible. Keep it like this. No slanting. It must be correct. 90 degree must be correct. Then draw the next tangent like this. Okay. Then again keep it here. For that you have to rotate the protractor and keep the 90 degree, and that line must be in the same. Then only that point must be visible like this. Then draw the next one like this. Then one more point is there. Keep the protractor again in that line. Keep it like this. Only that point must be visible. Then draw the next tangent. Okay. After this, use a scale and extend the tangents so that all the corner must be joined. Using scale, you can join like this. Now you can see all these points are joined. So this is the rhombus inside this figure. This is 140 degree and this will be what total 40 degree will be here, 140 degree here, here also 40 degree. Okay. Now mark that anchor. So this is 40 degree. Radius is what? 2 centimeter is the radius. So this is the method to draw this figure. Okay. Just by drawing the tangents. Tangent is always perpendicular. That's why we are using protractor. One more method is there, but compared to that, this one is better. That's why I use this. Okay. For the next method, you have to use the compass, and some more steps are there. So this one is better. So this is the answer for the second one. Next question. What sort of a quadrilateral is formed by the tangents at the ends of two perpendicular diameters of a circle? Here in this question, we have to find which type of quadrilateral is obtained by drawing tangents from the end points of mutually perpendicular diameters. Okay, mutually perpendicular diameters. So here these two are mutually perpendicular diameters. AB is the first one, then CD is the second one. Okay, now we have to draw tangents from all these 4 points. Then we have to check which type of quadrilateral is that. Now here we know, we can consider this center point as O. We know all the tangent through the point and the radius or diameter through the point will be perpendicular. So if we draw a tangent using protractor here, it will be a straight line. 90 degree here no. So this is 90 degree means if we draw a tangent same like the previous method, if we draw a tangent here, it will be a straight line. Similarly the next 4 will also be what? 90 degree line. Here 90 degree, here also a perpendicular line, here also one perpendicular line we will get. Like this we will get. Here CO is a radius and AO is also a radius. These two are radius, and this line is also a perpendicular line, means what will be what is the speciality of these two sides? These two sides will also be equal. Okay, so these two sides equal, these two sides equal, here also same equal measurement. That means the total this line is equal to this baseline. Okay, P Q R S. PQ will be equal to RS, then PR will be equal to QS, because PC and CQ equal, RD and DS is equal. That means opposite sides are equal. Opposite sides are equal and all the angles are 90 degree also. Then which type of quadrilateral? It's a square. Okay, it's a square. That means if we draw tangents from the endpoints of mutually perpendicular diameter, we will get what? A square. Okay, we will get a square. This is the answer for the third question. This is third one's answer. Nothing, simply by drawing the figure you can prove this. Okay. Next one. Prove that the tangents drawn to a circle at the two ends of a diameter are parallel. This is a rough figure of this question. Question is, prove that the tangents drawn at both ends of the diameter. Here AB is the diameter. A is the endpoint, B is the endpoint. Okay, second endpoint. From these two endpoints, we have one tangent PA and QB. Okay, we need to prove that this PA and QB are parallel. PA parallel to QB. This is what we need to prove. So for that, we know radius and tangent is always perpendicular. Okay, so OA is a radius, or AB we can consider as diameter. Radius perpendicular means diameter will also be perpendicular. So here AB is perpendicular to PA. AB perpendicular PA. Similarly, AB is perpendicular to what? QB also. Okay, AB is perpendicular to QB. That means both are perpendicular. That means what is the speciality of angle there? Angle PAB equal to angle QBA. Angle QBA equal to what? Perpendicular means these two angles are what? 90 degree. This is 90 degree. Here also 90 degree. So 90 degree means these two lines. What can we say about these two lines? 90 degree, exact 90 degree in between means these two lines PA and QB are parallel. Then only we will get 90 degree. If it is not parallel, for example, if one line is like this and the next is like this, 90 degree, it is not 90 degree. Okay, here 90 degree, but here it is not 90 degree. If it is so, we can't say these two are parallel. Only we can say if both the angle, okay, if these two angles are 90 degree, only we can say that these two lines are parallel. So here we got both the angles are 90 degree, therefore PA and QB are parallel. Okay, so this is fourth one's answer. So first section over. So hope you understood. Thank you. See you in the next video with the next section.